Okay, so I'm going to make a quick video for some of these examples that were missed in the first one. Um, so real quick, just to review synthetic division, I'm going to work number 3, and then I'm going to go over the remainder theorem and then the factor theorem. Okay, so the way we're going to do synthetic division, the way I like to do these is, first thing I have to do is take the denominator, set that equal to 0 and solve, so that'd be x equals 1. I call it my magic number. And so I like to make half a rectangle right here, and I put my magic number right here. And then what I'm going to do is I'm going to take the numerator, the top, and I'm going to write out the coefficients, the values in front of the variables. Now, if you notice that there's any that are missing, like I have x to the third power, but there's no x squared, and then I have x to the understood 1 power, you have to fill in zeros. So I'm going to have a 5, then a 0, then I have to put a -2 right there. So you take the sign with it, and then I put a +4. Okay? And synthetic division is actually pretty simple. You just have to, do it a couple times, and then you'll have the process down. So first value, you drop it. So drop it down. And then this is the process. You're going to come here and multiply. Okay, so 5 times 1 is 5. And then that value goes right here. And then now you're going to add the column together, which is then 5 in this case, 0 plus 5. And then I do it again. Go over here, multiply by my magic number. I get a 5. Add this together, and I get 3. Then multiply. Just so we can kind of see this. Multiply again, then put that number right here, 3. 3 plus 4 is 7. So now the synthetic division process is done. And what I need to do is kind of put everything back together, okay? And this is going to be my remainder right here. So what the synthetic division did was we divided everything by x plus 1. And so the x part is going to reduce all the powers by 1. And so what we're going to do is we're going to put those variables back, but they're all going to decrease by a power of 1. So this will become a 5x squared. Then this will be a positive, so plus 5x. And then I have that 3 right there, plus 3. So that's where all those come from. And so you just go down a power, and you just go in order. 2, 1, and then we didn't have a variable here. Now, my remainder is a 7, so you always put the remainder over your original divisor, which was x minus 1 in this case. Okay, so that's a review of dividing polynomials using synthetic division. So now we're going to look at the remainder theorem. Okay, and so really, it's the same thing that we did up here, except that you're going to kind of understand a little bit more about what the remainder actually accomplishes. Okay, and so you'll notice this problem is actually the same as the one up above, okay? And so what you're going to notice right here is it wants us to evaluate f of 1. And if you really wanted to, and in this problem it wouldn't really be all that difficult, if you plugged in f of 1, you would, have 5 times 1 to the power of 3 minus 2 times 1 plus 4. And so this would become a 5 minus 2 plus 4, and you add that all up, that's going to equal 7, right? You see it equals 7. And so the connection that we're trying to make here is that you can evaluate a function using synthetic division, and the remainder is actually the return value, your y value. So you let x equal 1, you let x equal 1, and it came back as a 7. So when x equaled 1, f of x, or y, equals 7 in that case. And so that's all this really is just a little bit of a faster way of doing it. And so if you really wanted to, you could evaluate the function like I did here, but you'll notice I'm going to have an example in a minute where it's a fraction. And once again, if you really wanted to, you could plug it in, but you'll see that synthetic division is actually a faster way. So I'm going to go ahead and skip this next one. Let's get to the one with the fraction. Okay, so here's the one with the fraction. So if you really wanted to, you could take 2/3 and plug it in each one of these spots and raise it to the 4th power, raise it to the 3rd power, 2nd power, and it would be a complete mess. It would be a mess because you'd have all different denominators, and you'd have to get LCDs, and it would be a mess. So that's where synthetic division comes in kind of nice. So the difference here is it's telling me what I'm evaluating. So it's giving you that magic number now. That's my magic number. So if I'm setting up the synthetic division, my magic number is 2/3. So don't change the sign of it. Okay. The difference here was you were dividing by x minus 1. You set it equal to 0 and solve. And so the difference here is we're explicitly giving you the value that we want you to use, 2/3. Okay. So now I'm going to fill this out. And so let's see, we're going to start with 12, and then there's an understood 1 in front, so we'll go to 1, and then -6, and then I'm missing my x to the power of 1, so it has an understood 0 in front, so we'll put our placeholder there, and then I have a 5 right here. All right, so the first thing we want to do is drop down the 12, and then now we're going to multiply it by 2/3. So the easiest thing to do is multiply by 2 and then divide by 3. So 24 divided by 3 would be what? 8. So we'll put an 8 here. Then 8 plus 1 is 9. 9 times 2 is 18. 18 divided by 3 is 6. Okay. Then that adds up to 0, which makes the next one easy because 0 times 2/3, that'll just be 0. And then 0 plus 0 is 0 again. And then that makes this pretty easy. So we get a 0 here. Okay. And then you add that together, and that will give us 5. So the answer just happens to be 5 this time. That is the remainder. So f of 2/3 equals 5. It's just kind of a coincidence that it ended up being the 5 on the end. It could have been something else, but in this particular case, it worked out pretty nice. But it would have been pretty messy to plug that in where we see x and simplify everything. That would have taken quite a bit of time. Okay, so this next part's going to lead us into the next lesson, and that's going to be basically using this to help us factor. Okay, so if you look at this problem right here, it's to solve this equation. So they want us to figure out, what makes it equal 0. And if you look at it, it's not factorable. You can't do factor by grouping. You can't do the quadratic because you have the cube. It's not factorable in its current form. But what they're going to do is they're going to say, given that 3 is a 0 or basically a factor. As a factor, that would actually be written as x, let me fix that, x minus 3. X minus 3. That would be it as a factor because the solution to that factor, what makes that factor equal 0, would be 3, right? 3 minus 3 is 0. So they're telling you right there that that is one of the factors, that 3 will give you basically a remainder of 0. 3 will give you a remainder of 0. So let's go ahead and do that. So come here, I take my 3. And so then I'm going to take all this stuff right here. I'm going to take the 2, the -3, the -11, and the 6. And what will happen here is my remainder will be 0. So let's see. Bring down the 2. 2 times 3 is 6. 6 plus -3 is 3. 3 times 3 is 9. 3 plus -11 is -2. -2 times 3 is -6. So you can see I have a remainder of 0. So this is the main takeaway that you want to get from this, okay? Now, remember what happens here with this polynomial is we divided it basically by this factor x minus 3. So this goes down to being a 2x squared plus 3x minus 2. That's basically what's left behind after I do my synthetic division. So the point that I want to make here is that we basically actually factored this. This turns into an x minus 3, and then this breaks into 2x squared plus 3x minus 2. So we basically just factored this down, okay? If you were to multiply those two polynomials together, it would go right back to the original. Now, we don't want to do that because what they want us to do is finish solving it. So we know 3 is the solution, and that helped us with our synthetic division. And what we did was we're breaking the polynomial into smaller pieces. And the good news is now I have this smaller piece right here, and I believe this one's factorable. They won't all be factorable. Some of them we might have to do the quadratic formula. but this particular one, I'm pretty sure is factorable. So let's look at this. So I still have my x minus 3. That was part of what I broke off. And then I touched on some factoring techniques in class, and you can do that if you want. This one's not too bad, to where I'm just going to go ahead and do guess and check because I really don't have all that much room. So to get to 2x squared, I'd have to break that into 2x and 2. Now, to get that negative 2, my only options are 1, negative 2, or negative 1, and positive 2. And now I got to figure out where to put each one. And just from experience, I know that this one's going to be minus 1, and this one's going to be a plus 2. And if you see right here, this would multiply to give you 4x, negative 1x, and that's where that minus 3x shows up. I'm sorry, that's where that plus 3x shows up in the middle. And then you can see that when you multiply the negative 1 times the positive 2, that gives you that minus 2 right there. So I know I did it correctly. I know my factoring was done correctly. So in the end, all my solutions are, the first one's going to be a 3. That one was actually given to us. That was given to us in the directions. This solution right here, you set it equal to 0. That would turn into a positive 1/2. And then the last one would be a negative 2. And then the order that you list them doesn't really matter, but those are the 3 solutions to this polynomial function. So let's try one more to get some more experience with this. And like I said, the next lesson is very similar to what we're doing here. We're just going to introduce one extra little part to it. Okay, so right here it says solve the equation again. Okay, so equals 0. Given that negative 3 is a 0 of a multiplicity of 2. So what that's saying, first of all, negative 3 is a solution. So as a factor, that would be written as x plus 3. And so this time it's saying there's a multiplicity of 2. So that means we're going to be able to do it twice. Okay, and so this will be kind of interesting. We probably haven't seen this yet. We're going to be able to use that number twice and get a remainder of 0 both times. Okay, so I'm going to break this down for us. So my magic number is going to be the negative 3. Okay, now I'm going to go ahead and list my coefficients, and it doesn't look like I'm missing anything, so I don't have to have any placeholders. So let's see, we're going to have 3, 17, 19, negative 21, and negative 18. So I'm going to drop the 3 down. 3 times negative 3 is negative 9. That's going to add to 8. 8 times negative 3 is negative 24. That's going to add to negative 5. Negative 5 times negative 3 is 15. That's going to add to negative 6. Negative 6 times negative 3 is positive 18. And look, remainder of 0. Okay, so just to make sure we completely understand what's going on, I want to write what the result of this is, and then we'll go a step further in just a second. So we got one of our x plus 3 factors, and then what we were left with, and I'm going to drop it down to power, taking these numbers right here. This is going to become 3x to the 3rd power plus 8x squared minus 5x, and then minus 6. So what I did was I basically factored this. I basically factored it. And what it's saying is I'm going to have a multiplicity of 2. So there's actually going to be 2 of these. So now I'm going to do the process all over again with what I have right here. Okay. So instead of having to rewrite everything, I'm just going to continue right here. So put my negative 3. I'm going to take those values that I received from the first time I did it. Okay, and just don't worry about that 0. So I'm taking those numbers right there. I'm basically getting it from right over here. And I should get a remainder of 0 again. So let's see if that happens. Okay, so we're going to drop the first one. 3 times negative 3 is negative 9. That adds up to negative 1. Negative 1 times negative 3 is positive 3. That's going to add up to negative 2. Negative 2 times negative 3 is positive 6. Remainder of 0. Okay, so you can see that happened again. So now what happened is we're breaking that one apart. So let me get a little bit more room down here. Okay. So we still have that one. We still have the x plus 3, and now we broke that one into an x plus 3 also. Now we get that from my magic number right there. That magic number as a factor is going to be x plus 3, because see, the negative 3 would cause that factor to equal 0. Now I'm going to take this and write that as my what's left over when I break it up. So let's see, that's going to be a 3x, and then we break it down to a power of 2. We go down by a power. Then we're going to have minus x, and then we're going to have a minus 2, okay? And this is all equal to 0. So this is identical, or well, it's a different form, but it's the same as the original one up here. But what I've been doing is factoring it by using synthetic division. So the last thing I have to do is, now that whenever you get it down to a trinomial, then it's time to factor or do the quadratic formula. And I don't think any of these on this first part we're going to have to do the quadratic formula, but in the next section 3.4 we will run across that in some cases. Okay, so let's see what we got here. So we have our x plus 3. You could write it as x plus 3 squared if you really want to. That's fine. Now, once again, I mean, I have a little bit more room, but I'm going to go ahead and do guess and check again. Okay. So I have to figure out what multiplies to give me 3x squared. I really don't have too many options. It's got to be 3x and x. So that's 3x squared. Now, how do I get negative 2? Once again, it's going to be 1 and negative 2, or negative 1, positive 2. And I got to figure out where each one would go. And this, once again, just from experience, I know that the minus 1 is going to go here, and the plus 2 will go here. And if you were to FOIL it together, you would see that the outer and the inner add up to that minus 1 in the middle, and obviously the last two multiply to give you that minus 2 right there. So we have actually only 3, okay, because we have a multiplicity of 2 on this first one. So really only list the negative 3 once, and that was the one that was given to us. Then the solution to this factor right here would be negative 2/3. And then the solution to the last factor is going to be a positive 1. Okay, so I hope that helps. If you have any questions, let me know.